So first of all, a question: who of you, if you're a software developer, who of you likes to test? Who of you likes to write tests? Okay, everybody should raise their hands because tests are very important. Tests are inevitable to create working software. But yeah, first of all, hi from my side. My name is Sebastian Daschner, or you're probably more familiar with this way of writing, right? So I'm a software developer. I'm a Java consultant and trainer and author from Germany, Munich. And I'm self-employed and help companies write better enterprise software. I do consultation, I do training and workshops for all kind of big enterprises. And I also help standardizing and evolving Java Enterprise. So I'm in several expert groups of the Java EE and Jakarta EE technology in the future. So we help defining to specify these standards and the standard technologies. And I'm also a so-called Java champion, an Oracle developer champion, and so on and so forth. And yeah, a speaker on conferences like this. And I'm very happy to be here. This is my second time in Russia, actually, and the first time in Novosibirsk. And yeah, I've never been here, and it's very exciting to see such a place. And yeah, so for this session, this is almost my last slide, because I will do live coding or live testing only. So all of it will be done live. We will have a Java Enterprise application that we want to test now, that we will test. So one very last slide, which is also about myself, just marketing. I do, as I said, consultant work and workshops and trainings on topics like this, on enterprise application testing, testing these applications, distributed systems, and so on and so forth. You can go to my website, sebastiandaschner.com. To see that. So now for today, what we want to do, we have two enterprise applications, one that uses an external system and that we want to test. And maybe you know, ja, lubię coffee. So we will have a coffee shop application that, where we can order coffee and that uses another external system to do so. And now we want to test that. Test it in an effective way, test it in a manageable effort, so that we don't get stuck in writing all these tests, right? Because we want to focus on writing enterprise applications, right? So what I have here is basically a project that I call JBreak Coffee, and it is a coffee shop application that uses a Java EE7 application here, and that is then deployed to an enterprise system. And it also uses a second application. So how that looks like, and I said almost no slides, but just this is why I have these code demo slides. I think they're nicer. So what we have a coffee shop application that uses a database where the user can access it with a REST interface and create new coffee. And then asynchronously, it also uses a processor that processes these coffee orders. So just in order to have a really real-world example, we have an enterprise application that uses a database and that uses an external system. And now we want to test that not only on unit level and unit test level and code level test, but also on end-to-end tests. Because this is what we ultimately need to have. Because why do we want to test? We want to test to be sure that everything in production will work later on, right? So in order to do so, we not only test the business logic with unit tests, but we also want to test the application in the same way as it would run in production later on. By accessing REST interfaces, by ensuring that the overall interfaces, that the interaction will be in the very same way as it will run later on in production. Because only then we can be sure that it really works. Otherwise there may be small differences, and these differences may break in production, right? So let me briefly walk through this coffee shop example in the code. So I only prepared the production code for you. I didn't prepare any test code. The test code will be live coding only. So what we have our Java EE7 application here. And one thing that we want to do is we have an orders JAX-RS resource. Who of you knows JAX-RS from Java EE? JAX-RS resources, yeah. Most of you. If you have any questions, by the way, I forgot to mention, please ask immediately. Just raise your hand and interrupt me. Questions are good. The more questions you ask, the more I can answer you, and the more I can direct the topic to answer these questions. So this is quite simple for now. We have a REST interface, an orders resource where we can post new orders, where we can get orders and, well, order new coffee. For example, we can get all the orders of the database. That gives us a JSON array that outputs all these coffee orders. A coffee order is an entity bean that is stored in a database, table orders, and it has an ID and a coffee type, for example, espresso. This is an enum. And then an origin, a country where it comes from, the coffee beans, and a status. What is the status of my coffee order? So this is quite straightforward. We store these coffee orders in a database, and we can order new coffee via these resource, and we can then retrieve these coffees as well later on. All right, and then as another thing, we also have a timer that looks for unfinished orders every 20 seconds. And now asynchronously, I told you, we create these orders at the system, and now asynchronously every 20 seconds there is a poller, and these coffee orders will be sent to the external system, to the order processor, if they aren't finished yet. So that is the idea of this asynchronous process, which we later on will also test. So we will need to take that into account. And what it does, it loads all the unfinished orders from the entity manager and then processes them. And what it does, it uses the JAX-RS client to talk to the coffee processor system, to the second system, to process that order, to send it to the second system in a JSON response. So anyway, now, do you have any questions to that setup? This is now our enterprise system setup with 2 applications. We will deploy them to a Kubernetes cluster. Who of you did use Kubernetes already? Maybe. All right. So just briefly, what is Kubernetes? It is basically a cluster solution to run Docker containers in an overall production cluster. So not just on one machine, not just on one laptop, but how to run our workload in production with a clustered scenario where we have multiple hosts, where we can orchestrate our payload, and where this technology will do that for us. So anyway, this will not be about Kubernetes. This is just our workload that we use. And let me show you this briefly. So it's already here on my machine working. What is this? This is my command line. Let's do this a little bit bigger. And here, kube control is the command for the Kubernetes cluster. So I have a locally running Kubernetes cluster where my workload is already running, and I have 2 services: the coffee processor. This is the external processor system, and Jailbreak Coffee. This is my coffee shop. So what I can do, for example, I can go and ask coffee shop Kubernetes local to give me all these Jailbreak Coffee, all these coffee resources, for example. And then we can see I get a JSON response back with a hypermedia REST API that I have. For example, they can tell me where I can see all the coffee types or where I can order new coffee. And for example, if we go to orders in the system, then we see that the system now is empty. There's an empty array. We don't have any orders in the system yet. So, for example, we can create a new order if we want to, and now that create order will post a new coffee into our system. So we want to have a new espresso with coffee beans from Colombia, and now we order this, and now this is in the system. Let's see. Now we have a new coffee order in the system, and it's also already finished, since it uses used the external system. And at some point, if we ask again, then it's already collected. So these statuses are updated in my in my cluster, as I said, I have two applications running, my coffee shop and the external system. And already the application uses that external system to update these statuses. All right, this is my setup for now, and now we want to test that. And actually, I don't want to start with unit tests. I want to start with the end of the testing pyramid, because these tests are mostly lacking in enterprise projects, as I see it. When I come into projects, then mostly there are no or not many end-to-end tests. And what do I mean by end-to-end tests? Basically, we want to test the overall application in the same way as it would run in production, with all the external concerns being mocked away. So that means we want to test our coffee shop application, and we want to mock this coffee processor, this external system, and depending on the setup, maybe we also want to mock the database, so that we just test our application, the one that we are writing, in the same way as it would run in production. Right? So that we can really be sure that everything works with all the endpoints, all the REST endpoints, with all the synchronization, transaction management, everything end to end, that once we deploy to production, everything works because we tested everything in the same way. Now, why I'm using Docker and Kubernetes? Because these technologies make it really simple to build our binaries once, our Docker image, and then use the same Docker image in all these environments. Because then everything is the same, there are no changes, and nothing can break in production once we deploy. And then now in order to create these tests, let's remove all this again, we want to create a system test that therefore connects against our application and tests it in the same way as a user would use the application, right? For example, what I just did, create a new order and see if the order is in the system. That would be an end-to-end test, a first one, a test scenario. Let's write this. So what I have down there is a second project that is empty for now as well, that I call JBreak Coffee ST for system test. Why do I want to have a second project? Because I don't want to have any dependencies to my classes in the first project. I basically test my application as a black box from the outside. So I don't reuse Java classes and so on and so forth. I just connect against my application. So that means I use the test package here, and I write, let's say, an order, a coffee order system test. And this should be a JUnit test, so that tests my application. And basically what I want to have, test, let's say, create order. And now in order to make this work, I need some dependencies. In my test project, what do I need? JUnit, because I want to use JUnit. So I use JUnit 5 already with the JUnit 5 API and Mockito, because we mostly need this. And then also what I want to have is a JUX-REST client dependency. Why? Because I will connect against my application. Now I can use any technology that I want. I can use Python, I can use even something else than Java, but I'm a Java developer, so I want to have a Java in my system test as well. Let's include the test scope for all these dependencies, that's cleaner. And also I want to use the Java EE dependencies, so JAX-RS on the client side. JAX-RS client comes with Java EE, so I'm already familiar with the API. This is why I want to use it. And now the interesting thing about that is import. How do we create these tests? And now this is really important, because if I would say, I go here and connect against my external system, my coffee shop, and then I check that HTTP response is 200 OK, I see the JSON output, I get the information, and so on and so forth, then this will not be maintainable. Because what happens if I want to have a second test, what do we do in projects? We take all this block that I just named, copy-paste it to the second one, change a few things, and then we have a second test. And then for the next test, we take these two blocks, copy-paste it, change a few things, and once you do this for 10 times, then it's not maintainable anymore. Because once a small thing changes, just forget it. You have 100 places where you have to change these things. Therefore, The most important thing to keep in mind to have maintainable tests is you have to care about code quality also in your test code. And this is really important. And the most important things in regard to that is build proper abstraction layers, even in your test code. Because then you have several layers of concerns of what you want to care about, what you want to test. That means, first of all, let's say we want to create a test scenario. So actually, what do we want to test here? Let's say we want to create a coffee order, and then we want to see if that coffee order has been placed in the system correctly. So we create an order, and then we read it, we see if it's there. Easy. And now we look at, having that said, we look into the test on really a perspective that a QA developer would have, that a tester would have. So that means we want to create the order and then see if it's in the system. And now you can actually, no kidding, start to write that on a paper, on a piece of paper. What are your test scenarios? Like this is a really simple scenario. We will have a complex one later on. Because now I don't want to care about HTTP, now I don't want to care about status codes or JSON or how we implement it. No, I just care about how my test scenario looks like on a very abstract level. So what do we want to do here? Basically, create coffee order, let's say with Colombia and espresso. With this information, all right, second then, let's see, check if coffee order is in system, verify origin is Colombia, if I could spell, and the type is espresso. Something like this. This is my test scenario, how it looks like. You see, I didn't write anything about HTTP, about JSON, about status codes. If I would do so, then we get in the same scenario that I just mentioned. So if I would write here, please post that JSON to the URL this and that, and then verify status is 200 OK, and so on and so forth. If I would write this and so on, then we get really in this scenario where we have not maintainable tests. And this is why I advise developers to create what we want to test in comments first. Write it on a piece of paper, write it in comments, and only now what we want to do is that we want to carve these things that we just wrote here in comments into a separate layer of abstraction. So basically what we want to have, we want to create, I call this now a coffee order system, and this will now be a delegate where we actually invoke all these things that I just wrote into the comments. So let's say we have a class here that I called coffee order system. This is just a name. That will be a class that represents my system, my coffee shop, that we want to test from the outside. So all the actions that we want to offer will be encapsulated in that class. So basically saying coffee order system, let's say get orders first, so we have the coffee orders, and then something like create order with Colombia and espresso, something like that, and so on and so forth. And now, once we create these APIs on these delegates, another thing that we want to take into account is that we don't have leaky abstractions. So for example, I don't want to have a JSON response here that will be returned from my coffee order. I just want to abstract all the information that I need in the proper layer of abstraction, right? So for example, what I could do is that I create a small type for order that represents a coffee order. That is more or less a representation of the order that I have in my production system. So basically this, right? Because I talk with my system and I get a coffee order. So I could use this and copy paste it, or even simpler, I basically say I have the same information here. I just copy then, but now of course I don't need the JPA annotations, right? I don't have JPA here in my system test. And also what I can simplify here, that I for example say I simplify all the types. So I don't care if the enum is correct here. Here now I'm in a system test. I test from the outside, and it could be any string. So in this case, I definitely can simplify here. It's a test scenario. Let's have some getters and setters. And then I have my system test representation of a coffee order. And now I can say, give me the orders. That one could either create a list of order, or in this case, a list of URIs of orders that will be returned from my system that I want to test. So this gives me all the orders. Now this is already another abstraction. I have a URI, which is fine because I define the URI is just the identifier of an order. I need to identify the order somehow, the ID. And the ID here should be a URI. Because I deal with internet systems here, so a URI is fine. This is not too much of an implementation detail. Because now, if I just have a general URI, these could even change. So my system is free to change these. All right, then I create this method. I will implement it later on. Now I want to create the order. Let's say I will have a new order here with, for example, let's create a custom constructor with origin and type. Then I will need another constructor for the serialization. And now I can create the order with, what is the first one? The type espresso. The second one, the origin. So this is now the order that I want to send against my system. Create order. All right, this should be fine. I probably get a URI back. So let's say order URI will be this one. And now next step, what I want to do, verify if it's in the system. Either I could write verify, or I'd write give me one order, please, of my URI. That, of course, gives me a new order back, right? I will now get my created order. I ask my system, please give me that order that I just created. And now what I can do, that I can verify that my order is the same. For example, I can say assert that. This comes from assert j, that the created order. Hello. What's up, IntelliJ? No, it's really slow. All right. Equals is has field is equal to comparing fields, is it? Basically saying, wait a second, there is something using fields is equal to comparing only given fields, and that basically says I want to create my I want to check that my created one is the same as the original order just by comparing the type and the origin. Basically, now I assert that this one is in the system, right? And that's basically it. And then at the end, what I could also do, ask the coffee order system to give me new orders, and then assert that the new number of orders, that the size is still the same, has size of the old orders plus 1. Agree? That is now basically my system test from a really abstract level. So like a tester would write these. Now it is readable because I only have a couple of lines of codes, and now I could exchange that I could change things that I'm doing here. I could create create new test scenarios, and I could enhance this one. That is the first level of abstraction. And now the second one is, let me just create a before method for the setup. So basically what I do here is you create a coffee order system. And now this is the implementation of how I talk to my external system. And again, this is important that we have this level layers of abstraction. So basically what I do, once I create this delegate here, I have a constructor that, for example, tells me, please create a client, a JAX-RS client, that will talk to the external system, right? So I have a target that is now my application that I want to test, so my coffee shop. I have another resource for my system test environment, coffeeshop.test. Kubernetes local, JBreak, coffee, resources, orders. So this will be the orders target. This is how I access my system. And now what I do, I implement all these methods. How do I get all the orders? Well, easy. I get to the target, say request. In this case, I know that it will be JSON, media type, application JSON, and then basically get, and I get everything into a JSON array. So I have my JSON array, JSON array orders. And now I can stream that, or basically get values as, this is easier, as JSON object. And now I have a stream of JSON objects. So basically these are all my, my JSON objects. And now I can say, from the object, please give me just the string. I want to have the URIs, right? So now let's see how this will look like. We can actually look into how they are returned. This is my system now, and it will give me JSON objects that contain a self link that gives me the URI to my order. All right. This will be that one. And then I have a string, a stream of strings. And then I create URIs. And then I create a list of URIs, and I'm done. I could even simplify this. It looks better. And that's basically it. How I get the orders, how I get the list of URIs, of order IDs. Any questions? Now, same story. If I want to create an order, what do? I post an entity JSON of my, well, I can actually post directly my order because I created entity JSON. I created this POJO in that way that I can directly post to it. And then I get a response. From that response, I can get the location, because this is what happens once I post to my system. I will get 201 created and a location header back, which will be the URI of my coffee order. That's it. What I can do also is that I say the response, the status, should be successful. So basically I can say if the status info, the family is not successful, then I throw an assertion error. Or I could also say assert that and use these methods. Same story. So let's say I say verify status. I extract that into another method. and then afterwards I get the location. This is how I now create a coffee order. Again, in this lower abstraction layer, if anything changes, for example, if the method how I get the URI changes, if the status codes will change, and so on and so forth, I only change it here, and I don't change my overall test scenario there. Now, if I want to get a specific order, same story that we had before, I say order target, and now I want to request. It's similar to that. Request JSON and get. Actually, here I can get the order directly and return this. This will actually throw an exception if the order is not correct. I could now also say I want to verify that the order ID matches a specific string, can do some regex checks, and so on and so forth. Everything on the correct abstraction layer. If I want to verify that, for example, all the protocol information sent via HTTP are correct here, I do it here in this abstraction layer. I don't do it in my test scenario. Here, I want to verify whether the overall information was sent correctly, if the status is correct, if the origin is correct, and so on and so forth. Any questions? We don't use what? Oh. Thank you. Very correct. We use actually the client to get the target of this URI. So the question was, we don't use the argument. Yes, of course. If I want to say orders target what I wrote before, then we get all orders. This is of course not wrong, not right. We only want to get this coffee order right now in JSON, and then we load it into our orders. All right. Now I want to test if my system test works here. So what I already have an installation, a running environment here on my laptop. So that means I have my application running in the same way as it would run in production, but the external system does not run in the same way. Because I don't need the external system. Later on, I want to mock the external system. So actually, the second test will be to create an order and to wait if it's processed correctly. So then we check if the external system, the second one, was called correctly. Here, we only check if the order is in the database, right? We create an order, then we load it afterwards, and if it weren't correctly in the database, then we will get some error here. The second, more complex test will be if also the external system was accessed in the correct way. So basically what we do here, instead of this simplified version, we have a Kubernetes cluster. And in the cluster, what we get for free are services. Kubernetes services are basically logical abstractions over applications. So our coffee shop is a service, our database is a service, and down there, our external system, the coffee processor, is also a service. Why do we need this? Well, now in a system test scenario, we can say we actually swap these things out. So we swap the coffee processor against a mock server. We don't want to have the external system, we just need a mock, like in Mockito. And Kubernetes simplifies this via these logical service abstractions. So basically, we always communicate with the external system in the same way as we will do in production. For example, let me show you the order processor. Again, here I only say coffee processor, just a logical name that will be resolved by DNS, by Kubernetes, and a port. And now in our system test environment, this will not be the coffee processor down there. Rather than, this will be a mock. The application doesn't know about that. The application talks in the same way to that processor as it would do in production. And now, the nice story about that is that we don't need to change anything in our configuration here. The DNS resolution will still work, now against another system. And now a system test can also talk to the mock directly and control the mock. For example, at first saying, please respond in this way. Now I changed something in my test environment. Now please respond in that way. Think of it like in Mockito on a system level. Same story, and now this is very helpful for our tests. So now what I have here in my Kubernetes environment, pods are the running containers. So this is what you saw before. These are my running pods with the services. So I had 2 services, ignore that one. I had 2 services and I had 2 running applications, right? And now I also have a service in another namespace. Another namespace is basically like almost like a second cluster. I have a system test namespace. And that also runs services that are now my system test environment. And for the pods, it's the same story. These are now different pods. And the second one, the coffee processor, is actually not really the coffee processor. It is just a mock. I can show you the Kubernetes description. What it is, this is the coffee shop processor. It basically runs my Docker image, WireMark. And WireMark is a technology, well, that is basically like Mockito on a server level. I use a WireMark server, that is a mock server for HTTP, to mock all these processes, all these requests and responses that the external system would send. So for my application, it looks the same way as it would talk to the correct processor rather than it talks to a mock. So now, what I want to do is that I want to test my system test here, and I'm now invoking my system, my coffee shop. So I run this test here, and what it does, it connects against my external system, and now green. I hope you believe me. This was now done against this target, and that one is almost the same that I created. I can actually show you the test order that was created. Curl. This is my production system. .test. This is now the order that has just been created. This is a different one with the test resource. All right. That was the easy part. Now let's do a little bit of complicated scenarios. Now we want to have a test that also sees order processing, that checks if an order will be processed correctly. Now, same story as before. First of all, only comments. What do I want to do? I want to create a coffee order. Right? And now I want to, well, verify coffee order. And now I want to see if verify coffee order processing, if the order has been processed correctly. So we have a couple of statuses. So first of all, our order will be in preparing status, so we wait until it will be prepared correctly. And now if we send that order against the external system, the status will be updated, hopefully, against finish. And now it will be sent again afterwards, and then it will be updated to collected. Basically, we invoke our external system twice, and once it updates to finished, and once it updates to collected. This is done asynchronously, so we have to wait, actually. This is also part of our system test. Status should be finished, and then status should be collected. All right. Now what we do is, again, layers of abstractions. We craft all these implementations into another delegate that I call now processor system. We set this up as well, new processor. And this will be responsible to basically talk to our WireMark, to our mock server, and control all these things. This is, of course, wrong. Processor system. And then what we do at the end, we also say processor system, well, reset. Because now the nice story is in our system test, we can talk to the external system and control it. At first, we want to say, do some basic mocks, and then at the end reset everything that you have done, because we will check if it has been called correctly, like we would do in Mockito, right? And now we set up. Oh, sorry, this is not set up. This is tear down. Otherwise, it doesn't make sense. So this is one method that we will create here in this delegate. and we will have a few other ones as well. So let's look into a first test. What do? We created a new order. Okay, we can reuse this functionality, create a new order. Right. Now verify the coffee order. All right. We will do the same thing like we did here. We get the order here and we assert that it was called correctly. Now what we want to do is we need to wait for the processing. Let me write that into another method. Now we want to wait that the order, let's say order URI, until the order is in status finished. Of course, with the timeout, if that doesn't happen, then the test should fail, right? And then at the end, we want to see if it's collected. In order that this happens, we have to talk to our mock system. Why? Our mock system doesn't know anything about coffee order. It just acts like we configure it. So basically what we want to say that our processor system, please answer correctly for the order. So now for our order URI, first of all, please answer with finished, right? Because depending on our coffee status, our external system will update it. Now we don't need our correct system. We just say, oh, now answer in this way, no answer in the other way. So it will first of all say finished and then will say collected. And our coffee order system will then update this appropriately. So wait for processing is basically another method that we call we tell our processor system to wait for the invocation for that URI and not finished but status, the correct status, and then we could also verify that now our order is in the correct status, right? So basically we get a new order and we assert that the status now is equal to status. So first of all, we wait for the invocation to our external system. Now we go against our first system and ask if the status was actually updated. And what we do here now is that we implement this one, wait for invocation, and of course answer for order. Again, layers of abstractions. We now already finished our test scenario. This is what we actually want to test, which we could enhance and change and so on and so forth. And now in this delegate, we will actually, do these. Reset. So what we want to have is mock server. WireMark. Oh, did I already include it? I don't think so. Yes, I need the WireMark dependency to talk to my WireMark server, right? Now let's see. WireMark reset. Yes, reset all. Does it? No, it doesn't have this. All right, now we want to reset everything, and at first, also what we want to do is we want to configure, for our given system. So now we connect against our WireMark system that runs under coffee processor, right? .test. Kubernetes local with a port 80 in our case. So we configure it first. And then we say, make a default response for a stop. So basically, WireMark, no, not get, but post. So post for our URI pattern, which is per default coffee processor resources processes. And this will, return a specific response JSON for a different for a specific status, like preparing. So per default, this always responds with the definition of preparing. Okay, for JSON, so it will have basically as a JSON response. What do we do now? We configure our WireMark system in the same way as we would configure Mockito, right? So per default, when you invoke something, then return, in our case, a JSON response where you can say singleton map key value status in a given status. Now please response in our status preparing. All right, stop for this. Reset as well. Now this is our default WireMark response. Now the interesting thing is answer for the order. So what it does, please configure stop for the following scenario, a post, same way what we had before, resources processes, now with a specific request body. Now I want to say if my request JSON looks like follows, that we have actually this order URI, right? And it in this case it won't be a URI, but actually just the ID, because we always post the ID against the system. So order ID will be extract the ID from the orders URI. This is because our URI is that whole thing, and what we want to post is actually just the last part, this ID here. Sorry, this ID here. So we need to extract that, and then we send the order ID against that system. So our mock server checks if the correct request body will be sent, and then it will return, well, a response to JSON with the actual status. Let me write this, finish this method. Order ID, this basically checks if the JSON is correct, equals, where is it? Mockito, WireMark is equal to JSON, and the JSON, well, we have different ways how to write this. I could, for example, write order is, in my case, order ID. A little bit of, bad syntax here. So this matches my JSON that will come back. I also write this extract method. Well, what it does is that it says take the URI toString and, well, do a substring of that with the last part, right? String last index of my character +1, so I get everything after the slash. This will be my ID. Anyway, I now configure the external system that it will respond in a specific way for my given order. Now, if my order will be sent, and this is now done by the first system, against the WireMark, then the mock server will return with that status. And also what's important here, we want to wait for the invocation. So actually now we want to ask our WireMark if that invocation has happened in the correct way, right? Yes? Oh, yes. Very good. Somebody pays attention. I like that. So what we do now is that we say, I think it's called find. This basically finds all the invocations that already have been made against my system. So they say what was requested, post requested for URL equal to what was requested against, well, coffee processor, resources processes. for that specific, well, no, not the pattern. With a specific request body, the same thing that we had before, request JSON, right? But not only the order ID, but also a status. So now we can, well, basically write a second method, and we also need to say, please ignore all the feeds that come that are sent more than this. Basically, this checks against the JSON, but it will ignore unknown fields. So if I send more than this, it doesn't matter. Order, and now the previous status should be status that comes in as the argument. String status, and it will check against that as well. And I will extract, where is it? I can copy paste the same thing here. I will extract the order ID, and then I will send the order ID against that one, right? And now it will find all the invocations that basically say, give me all of the requests that match this thing. And now what I want to say is that I want to check if all these, if that list is not empty. Did I forget? Yes. Right? So basically, while, that was wrong. Let's say requests something like this. While it hasn't been matched, please, well, try again. Wait for the actual invocation and then try again. So why it hasn't matched, please do, well, this is basically a wait. So we will wait for, let's say, 2 seconds or something like that. And then we ask again until we have some timeout, right? So system current time millis plus, let's say, 60 seconds will be the timeout, right? While that, yes, it's more than timeout, then, well, throw an assertion error. And then we could also verify, and so on and so forth, right? So what we do here, this will be a Boolean method, and we return request matched. So if it's not empty, and while it hasn't been matched, well, we check basically this until the timeout, right? Any questions? Do a write test for my test?
Yeah.
Yes. How do I do this? I don't trust any test that only was green. So you saw before I run the test and I said everything works, right? And it was green, and you hopefully believed me. This is bad, right? Because it either means I did everything right the first time, or it means my test is wrong, right? So never trust tests that always have been wrong. Let's see if that one works. So now my processing test, this will actually take some time. Because at first, yeah, that's good. Oh, wrong string. This is, for example, a good test. Now I see finished, but it was actually finished. Okay, so at least I see that my system responded something, right? If it would just be green, then I don't know what happened, right? But in this case, I say, oh, it's actually finished. So in this case, click to see difference. No, not this one, that one. Assert that is equal to status. So actually, this is true. My system will respond, well, in this case, which is fine. But that was a good test to see if everything worked. And in a second, if that runs, I can do the same thing for the first test that I wrote first. Because very true, if it was only green all the time, then I don't know if it actually worked correctly, right? So let's wait for a couple of other seconds until that one happens. So now what happens? I go against my system, create an order. Now my system is configured that every 20 seconds it will ask the external system. Before I configured the external system for that very order that I just created, please always return finished. Okay. My system will now go against the external system will tell finished, fine, then it will be finished. Then same story with collected, that is the end status. I again have to wait, for, well, 20 seconds basically, until that happens. And then same story, it will respond appropriately, and then, well, hopefully it will be green soon. If not, then after a minute the test will fail. And then I see if everything works, right? Very good, it didn't work. Live coding, this is very good, because then I can show what we do in this case, how we can debug it. Do you have any questions at this point?
Yeah, maybe you need to correct finish to camel case in other lines when you configure your mock. So
no, actually finished. This system always returns finished. What we can do, first of all, we look into, where is it? That specific invocation that was here. So that actually didn't happen. That is already the first invocation. So we will see what was wrong there. So request matched. What we can do, for example, is that I create a breakpoint, and then I, well, basically do this again, because my application runs in a second thread anyway, right? So I see, yeah, please find all, and so on and so forth. And then I can see if everything, well, was done correctly. So I can say, for example, URL is equal to, I can basically now debug everything here. This is what I could do. Find all, and now see if everything there works as expected. Now you see these are the actual invocations that happened during my system test. It's a little bit small. I hope you can see it. And if I would invoke this one, then it's obviously empty because it hasn't been invoked. So I can see what was the actual data that has been sent, and maybe I have some. There is a mistake in my. Did I do this correctly? Well, yeah. There is a mistake in my invocation, right? So what I can do, I can take this and say URL equal to, and then also with request body, right? First of all, just check against the order ID, and now it says, oh, it found something, right? So it actually was invoked with that, and what I can do then, look into the actual request body, which is here, unfortunately, only a byte code, a byte array. So we had to look into what was wrong there. But let me just see if I quickly find the error status. I don't know, if I don't see an error right now, then I can't, well, debug it in time. Then you have to believe me that this can be green at some point. But this is basically what you do then, right? So here you have a code level invocation, so you could debug it and could look into what actually happens. Because what we do have now is that now we talk against the mock. And while the system test is running, I could also talk against my mock from a REST endpoint and ask what invocations have been made, right? So either my test was wrong, which is the case here, but I don't find it like in time until the time is over, right? Or my externals, my system that I'm testing did communicate in a wrong way, right? And now I can debug, look into the mock server, how it was actually behaving, and so on and so forth, and then I see the correct outcome. Any questions left? I'm sorry that it doesn't work right now. This is live coding.
Thank you very much for questions. We have no time now.
Yeah.
But we have discussion zone when you can. Ребята, сейчас скажите спасибо Себастьяну за прекрасный доклад.
Спасибо.